In this lecture, we'll continue to look at our place in the universe. And we'll start by looking at what we know about the history of our cosmos. Observations show the universe is expanding. The space between galaxies is actually increasing with time. This implies that galaxies must have been closer together in the past, and if we go back far enough, we must reach the point at which this expansion began. We call this beginning the Big Bang, and astronomers use the observed rate of expansion to calculate that it occurred about 14 billion years ago. The universe as a whole has continued to expand ever since the Big Bang, but on smaller scales, gravity holds things together. The stars within galaxies and galaxy clusters do not expand. We, as people, do not expand. Within galaxies, clouds of gas and dust collapse to form stars. These stars shine so brightly because of nuclear fusion in their cores. The nuclear fusion produces new elements. Hydrogen gets converted into helium. It's true alchemy. Stars eventually run out of nuclear fuel, and when they do, they explode, spreading their atmospheres with the elements they produced at their cores into the galaxy. New stars will be formed from this material, and the cycle continues. Everything on Earth, all of us, are made of elements that were produced in stars. The material from which Earth is made was created inside stars that lived and died before the birth of our sun. My favorite astronomer, Carl Sagan, was fond of saying that we are all star stuff, because it's true. The calcium in your bones, the iron in your blood, the carbon in your body, it was all formed inside of a star. You know Earth is moving. It doesn't feel like it, but it is. And this motion is fast and perhaps even crazier than you might imagine. Earth rotates once each day around its axis from west to east. This is counterclockwise if you were viewing Earth from above the North Pole. This motion is why the sun and stars appear to rise in the east and set in the west. We are whirling around Earth's axis at a speed of more than 600 miles per hour. We are also revolving around the sun, one orbit each year. We don't feel it, but it's about 60,000 miles per hour. The Earth orbits the sun in the same direction that it rotates on its axis, counterclockwise as viewed above the North Pole. Our entire solar system is also traveling through the Milky Way. Stars in our neighborhood move essentially random relative to one another, but it's fast. On average, our sun is moving relative to nearby stars at a speed of about 40,000 miles per hour. We don't see this motion because stars are so incredibly far away. Over thousands of years, this motion will be evident, though. In about 10,000 years, the constellations we see today will look quite different. And in 500,000 years, we won't be able to recognize them at all. The seemingly random motions of stars in the Milky Way give way to an even simpler and faster motion, the rotation of our galaxy. Our solar system makes one orbit around the galaxy every 230 million years. We're moving around the galaxy at an incredible 500,000 miles per hour. Within our local group, some galaxies move towards us, some galaxies move away from us. At least two small galaxies, the Large Magellanic Cloud and the Small Magellanic Cloud, are orbiting our Milky Way. The speeds are enormous. The Milky Way, for example, is moving towards the Andromeda Galaxy at about 180,000 miles per hour. In about 4 billion years, the galaxies, the Andromeda Galaxy and the Milky Way Galaxy, will plow into one another. But don't worry, the stars inside each galaxy are so far apart that they will not collide. Nevertheless, the stars will be thrown into different orbits around a new galactic center. Simulations of the collision show that our solar system will probably be tossed much farther from the galactic core than it is today. When we look outside of our local group, we find two things. First, virtually every galaxy outside our local group is moving away from us. And second, the more distant the galaxy, the faster it appears to be racing away from us. This tells us the universe is expanding. But remember, it's space that is expanding, not us or the stars within galaxies. The fact that we see all other galaxies moving away from us doesn't imply that we are at the center of the universe. A viewer on any other galaxy will also see all the other galaxies moving away from them in an expanding universe. A rising loaf of raisin bread is a good visual model. If you imagine putting raisin bread into your oven, as the raisin bread rises, each raisin sees every other raisin moving away from it as the loaf expands. In this model, each galaxy is a raisin. The difference is that, unlike raisin bread, the universe doesn't have a center and it doesn't have an edge. Okay, this slide summarizes our motion through the universe. The speeds are enormous. The next time you have the opportunity, go out at night, lie down, look at the stars, and start thinking about this motion. I guarantee once you start thinking about it, you'll start reaching for the ground because you'll feel like you need to hold on. We'll end this chapter talking about the human adventure of astronomy and how it continues to be an adventure. Humans have always looked at the sky in awe, in fear, in wonder. We are the universe. We are essentially a cosmic consciousness. So it makes sense that we look out into the darkness of night and we want to know. Astronomy offers us the best chance to answer our biggest questions. How did we come to be? Are we alone in the universe? Why are we here? Our species has invested enormous amounts of time and treasure to search for answers. We've built giant eyes to see farther into space. We've sent probes to the outer reaches of our solar system, and we continue to do so. We are so small, so tiny on the cosmic scale, but our curiosity of the universe is vast. I hope this course will begin to answer some of your questions about the universe, but I know it's likely that you will end up with more questions than you began with, and I don't think that's necessarily a bad thing. I'll leave you with this quote from my personal hero, Carl Sagan. "For small creatures such as we, the vastness is bearable only through love."